beaucoup. On va donner maintenant la parole à Gabriel Zachman. Il est full professor of the Computer Science Department in Bremen. Il s'intéresse beaucoup à la reconstruction et à l'aide à l'extension de réalité au bloc opératoire, dans le contexte du bloc opératoire. Et donc, il va nous parler de l'extended reality around the operating room and the future. Ça proche du sujet que nous a traité Patrick Nataf.
To share, you must have. Where is your keynote here? Document? No.
You can share the whole screen.
No. You must.
Et ça fait plusieurs années qu'il travaille sur ce sujet de extended réalité au bloc opératoire et dans son environnement immédiat. Donc on est en plein dans le sujet pour faire un complément d'information.
This one?
This one. Close this one. Just here.
Here?
Right. And
Just that. Just that. Yeah.
Thank you, Gabriel.
it's okay for you.
You can have 20 minutes and 10 minutes for discussion.
Okay. Okay. Thank you very much for the kind introduction. And first of all, I would like to thank Jean-François Hull for the invitation. Also, I would like to thank Jean-Guy Georges for proposing my name and establishing the contacts. And also, I would like to apologize to you. I do understand a little bit of French, but my French is certainly not good enough to give a presentation. So please bear with me. So in the following, I'm going to present some ideas and work on using extended reality for the operating room of the future or today. This is work that was done by my team over the past few years, which you can see here. First, I would like to present some of the outcomes of a Darkstuhl seminar that I organized about a year ago. In case you're not familiar with Darkstuhl, this is a really great opportunity to gather a number of international researchers for a whole week in a remote and somewhat secluded spot in Germany, so people cannot run away. And in my case, we gathered mostly computer scientists, but also for surgeons for a whole week. We did presentations. Attendees also gave demos of technologies and their work. But most of the week was used for ideation, doing roadmaps and creating ideas how to use extended reality for the operating room. Out of that came a collaborative paper on extended reality for enhancing surgery. And we're now in the first revision cycle, so we can hope to get the paper published sometime this year. And as you can imagine, when you gather a number of researchers for such a long time, a huge number of ideas come up, and you can see here an overview of some of the more bigger ideas. Obviously, due to time constraints, I can only show you some or go into details for the ideas marked in red. So one idea that we have also seen in an earlier talk today is remote collaboration. You can see the concept image at the bottom, at the top right here. So the idea is that a remote surgeon, expert surgeon collaborates or works together with a local surgeon who is performing the actual operation in the room. And there are a number of benefits and motivations to do that. For instance, access to healthcare, access to training, and so on. I guess you're familiar with all these benefits or potential benefits. This also presents a number of challenges, obviously. So in order to make this collaboration successful, we need to enhance the immersion still, also the embodiment between the remote and the local experts and surgeons. it's important to make multimodal information available to the remote surgeon. And this brings us to standardization and questions: how can you integrate such technology into the surgical environments for seamless interaction and operation and workflow? At the bottom right, you can see one early example that we have worked on a few years ago, where several surgeons can visualize a CT scan in virtual reality, and they can collaborate in virtual reality and discuss the case together. And they could be in different places, obviously. Another use case for extended reality is robotics. We have heard about that in a previous talk too. So again, benefits are better precision, reduced blood loss. Also, potentially, this lends to remote operations and other benefits. Again, there's a number of really tough challenges, such as precise registration between the coordinate systems of the robots and the local patient, registration between overlays in augmented reality and the anatomy, and so on. Quality of service of the network is also a big issue, such as latency or bandwidth if you're doing remote operations. It also turned out that extended reality has could have a number of benefits for the patients directly. So, for instance, you could use extended or virtual reality to communicate operation plans to the patients very intuitively. And maybe you could even take decisions together with the patient in virtual reality or while discussing the case in VR. It also appears that, or research has shown that VR could have a lot of benefits for distracting patients before an operation or even during the operation. It could help to manage pain during the operation or before anxiety, emotions, and this kind of stuff. So there are a number of opportunities there, and maybe you could even use virtual reality to test cognitive functions while performing a neurosurgery, and that could really be quite an interesting use case, which, as far as I know, has not been explored yet. In the second part of my talk, I would like to show you some examples of the work that we have performed in my team. And so obviously we have also worked on a virtual anatomy atlas. You can see a video here on the left-hand side. So surgery students can interact with the anatomy, display different structures. You get all the tools, the instruments. You also get magic instruments that you don't have in reality. And so this offers quite a lot of opportunities. On the right-hand side, you can see one example where we show that learning anatomy using virtual reality actually has benefits. And there are many other ways how you can do these studies. We have also looked at VR training simulators, obviously. Here you can see an example with hip surgeries. And in this video, you can see one of the very important steps in this whole procedure. And I guess you can imagine that haptics here is paramount. And the problem is that surgeons don't see anything, and it's very difficult to teach the haptic skills for this procedure. So we have built a VR simulator over the past years where we try to replicate the anatomy and also the forces that a surgeon would feel during the real operation. In this screenshot, you can see what the trainee would see in their VR headset. So virtual operating room, virtual patient, the access to the hip socket. And in the video on the left, you can see now how the system works. So the trainee is holding the real instrument in their hands and manipulate that, but the instrument is mounted to a robot. And through the robot, we can then output forces that a surgeon would feel in the real operation. And we have developed algorithms and methods to calculate really high forces with 1000 Hertz update rate, which is kind of the gold standard in force feedback. We have also looked at using XR in the operating room directly during procedures. So for instance, the lighting. As you all know, probably lighting always has to be adjusted and maybe readjusted during operations, which could cause distractions. And so we have done research in trying to make lighting systems more automatic or autonomous. In our approach, the idea is to do away with the moving lamps, but instead mount an array of light modules fixed on the ceiling. They can rotate and orient, but they cannot shift. And the system also comprises a camera, which you can see also in the screenshot at the top, these little black boxes. And they capture the whole scene around the operating table. And in this video, you can now see the system, or what the simulation does. It basically simulates the line of sight for each and every light module to the operating site and tries to calculate occlusions or visibility. And that way we can basically calculate optimal brightness for each and every lighting module such that you get a constant optimal lighting at all times, no matter where staff is standing or occluding which light modules. And what you see at the bottom, the recording is an actual recording of a real operation. And here you can see a physical prototype. So our partners in the project have built this physical prototype. And if you look closely, if you watch closely the modules on the ceiling, you will see that they gradually dim up and down and change the lighting depending on the situation around the operating table. We have also looked at the access of information during operations. I'm sure you're all familiar with situations that you can see on the left-hand side in the video. So frequently monitors are placed in the operating room at a distance. Surgeons maybe have to tell nurses what to change in the visualization, stuff like that. So we were wondering, can we place the visualizations as close to the operating site as possible, which means on the covering sheets of the patient. And this presents, and this video shows the setup that we're using in this research. So multiple projectors project onto the cloth. We use multiple depth cameras that are also mounted here on the ceiling, watching or recording the situation around the operating table. And that presents a number of scientific challenges, such as, can we undistort the image even though the surface is not flat? Can we handle occlusions, overlapping projections, and so on? And here you can see a video of our work in progress. So you can see how the system automatically undistorts the visualization, even if the cloth and the surface, the projection surface changes during the operation. So you can see it takes a little bit of time before the projection converges again to a sharp image. But this is necessary because multiple projectors produce overlapping images on the cloth. Here are some results. We can drive 3 projectors and 3 cameras at the same time on a single PC and do all the calculations in 20 milliseconds, which is pretty good. It's pretty much real time. We can also achieve 1.6 millimeters accuracy of the visualization on the cloth, even if the cloth is highly uneven and really not flat at all. Here's another video showing how the system works. So you can see the visualization follows the head of the surgeon. It always looks flat. And with gestures, you can even interact with the visualization. So the system has cameras, so we can do gesture recognition. And here you can see basically a user study or a recording of a user study that we are currently carrying out. And so basically surgeons could then click on buttons in the visualization. Lastly, I would quickly like to talk about tracking surgical instruments. I guess you are all familiar with this problem, which arises in image-based navigated surgery. The current approaches use markers that are mounted on the surgical instruments. This requires, of course, a line of sight between the camera and the markers. But then sometimes the line of sight is occluded or blocked, and sometimes the markers are stained, and then the system loses the tracking. So we were wondering, can we track the instruments without the markers? Because we already have the CAD model of the instruments. So we are using neural networks to try to track the poses of the instruments in the camera images directly. And this presents a number of challenges. So for instance, how accurate can the tracking be? What happens if instruments are partially occluded? What's the accuracy now? What are the update rates we can achieve, and so on. And in order to stay somewhat within the time limits, I'm just presenting here one of the results, which looks at the accuracy. How much accuracy do we get under partial occlusion of the instruments? On the right-hand side, you can see one such case where we are simulating an occlusion, a partial occlusion of a screwdriver. And you can see on the very right-hand side the ground truth. That is not visible to the cameras, of course. What the cameras see is what the blue and white image shows. And on the left-hand side, you can see the accuracy on the y-axis in millimeters. On the x-axis, you can see how much of the instrument is visible. 1 means it's totally, completely visible. 0 means it's completely occluded. And the green curve shows the accuracy we get with our approach. As you can see, in most cases, we are better than the state of the art, especially in this middle range of partial occlusion. And that brings me already to the conclusions. I think we can say that virtual reality is proven to be effective for training surgical skills and knowledge. And there are many, many studies we have seen in previous talks. We have seen other examples too that prove that. I would also like to hypothesize that virtual reality, AR, and artificial intelligence will become effective tools during surgeries in the operating room. And with that, I would like to thank you very much for your attention. Here's the QR code again. So in case you want to contact me later, feel free to snap a photo of the QR code. Of course, I'm also around today if you want to talk to me. And I'll be happy to answer any questions you might have. Thank you very much.
Innovation in the operating room. Some question for Gabriel? Joachim? Yes.
Hey, Gabriel, thank you very much for the excellent talk. I had 30 questions, but I'll summarize that in 2 probably. In the scenario where you have several light sources in the ceiling to replace the movable lamp, have you made a comparison of efficiency and the illumination conditions with the movable lamp scenario?
A comparison with the movable lamps. Sorry. So a comparison with the movable lamps is rather difficult to do. We didn't do that because it would be a relatively complex user study. What we did is we did actual measurements of our physical prototype. What is the lighting that we can achieve on the operating site? And that turned out to be really very constant. We also asked the experts. So we did expert interviews and they were really quite happy with that. We, of course, also did a number of simulations with our system that show how much is the fluctuation, the variance of the lighting situation in the operating site over time and over space and so on, but not a comparison. Yeah.
So, because this was tied to something else, people in Hollywood and now in Netflix, Paul de Bevets from SIGGRAPH fame, he has constructed this spherical dome with LED emissions placed at precise intervals. And I was wondering if you did some study with the optics manufacturer or considering the spacing and the intensity and characteristics of the lamps. I found that work very interesting.
Yes, thanks a lot for the question. That's a very good question, and we don't see it here. We did actually look at the placement of the light modules, and basically what we did is we tried to, or we ran a whole optimization procedure for a day or two and find the best placement of the lamp modules on the ceiling. So the regular grid that I showed earlier is the very first attempt. But in reality, if you wanted to have the best lighting, the optimal lighting with the minimal number of lamps, then the pattern would look much different. And we did a number of optimizations to find the optimal patterns given certain procedures, certain patterns of the staff around the table and stuff like that. So yeah, excellent question.
Thank you very much.
Other question for Gabriel? So we have Hudson, who is asking question from the Zoom session. Please, Hudson, you can ask a question.
Bien sûr, Gabriel, moi je voudrais savoir quel est l'avenir pour l'ophtalmologie. What do you think will be the future of ophthalmology in the subject that you explained?
Here we deal with all surgical specialties, 13.
Can you say it? Can you say it again?
All the surgical specialties, and especially ophthalmology for him.
Okay. And ophthalmology is surgery?
Yeah.
Eyes. Oh, I see. Sorry, I'm a computer scientist, so I'm not.
I know.
I don't know all the technical terms of the medical area. Yes, eyes is an interesting topic. I'm not aware of a lot of research looking at extended reality for eye surgery. So I think that could be a really, really good opportunity for computer scientists and everybody to do more research. I frankly, it's probably a very tough case because the structures are also so delicate and fine. So I can imagine that is a pretty difficult area. Maybe, I don't know, robotics could be a good opportunity to help there. But personally, I haven't looked into that area.
Because we are very advanced in ophthalmology in terms of 3D visualization. Nous avons la visualisation 3D très développée, but not for doing these robotic surgeries because we have to be the surgeon there. Il faut que nous faisons la chirurgie. C'est pas facile de faire la chirurgie par robot dans l'ophtalmologie. C'est le problème.
Was there a question? If yes, maybe someone can translate for me.
Just a comment, just commenting.
Okay, thank you very much.
Y a-t-il d'autres questions? Bon, Merci beaucoup. Merci à tous les orateurs. Alors, c'est incroyable. Toutes ces séances qui ont trait à l'anatomie réelle ou virtuelle ou augmentée sont absolument formidables. Après, on voit bien que il va falloir choisir. Et il faut choisir les indications des examens. Quel va être le plus performant, le plus frugal aussi, le plus écologique, en particulier avec les données, parce qu'on voit bien qu'on fait des progrès fantastiques, mais on se pose quand même des questions sur ces data centers. Euh, on espère que ça va marcher, bien sûr, on est optimiste, mais bon, il y a encore des questions. Merci en tout cas beaucoup à vous.
Merci à tous. Oui, il y a une inflation de données. Le problème, c'est ça, on est inondé par des données. Donc, comment les sélectionner de façon pertinente pour que le chirurgien puisse être efficace? Et autre remarque générale qui est très importante, la collaboration entre les anatomistes, les chirurgiens et les computer scientists est fondamentale dans toute cette révolution. Et je voulais les remercier d'être venus nous témoigner de tout ça. Merci. Joachim, tu as encore un mot?
Oui, je voulais faire une petite observation et donner un compliment à Gabriel Zachman, because Gabriel has organized in Dagstuhl a seminar where I had the privilege of participating, and we have 50-50 of computer scientists and real doctors, surgeons and clinicians.